Hi everyone, my name is Daryl Karamba, and I'll be attempting the chapter 5, the continuous probability distribution. Basically, this chapter goes from chapter 4, which has to do with binomials, which we know by now has to do with two different outcomes that you can get. So you have to sort of keep an open mind when you're doing both of these. You can't just divide it chapter by chapter. You have to think of statistics as holistically as possible. So in exercise 5.3, it talks about an accountant decides to sample paid invoices to perform a controlled evaluation of the cash disbursement system. Initially, he will only count the total number of payments made in error and disregard the type of error. The types of error are the goods were not received, the invoice amount was incorrect, or the bill was paid previously, which means that there's basically a mistake. And though at the worst, the accountant has previous evidence to show that about 6%, which you can when you're reading through these examples, you must just you don't want to read them over and over because now we're under time constraints if you're at a test. So when you're dealing with 6%, then you already know that you're working with your pi value. So your pi value is going to be equal to 6%, and then after, well, you can write it as 0.6, and then after that, and then it says 6% of payments are usually made in error. If 300 invoices, and 300, we know that that's going to be our n. Invoices are selected at random, determine the probability that, then it says at most 25 were paid in error. Now, when you're working with the continuous probability distribution, we need to be able to make sure that we can make certain assumptions and that we're working with the normal distribution over here. So there's two different things that you have to do. Number one, your n value has to be greater than your n has to be greater than 5. Yeah, so your n pi has to be greater than 5. So if we take the n multiplied by the pi, which is 300 times the 0.06, we're gonna get to 8 or something. 18. Yeah. Okay, 18. And then after that, then the second one that we have to do is lots of people make mistakes, but yeah, those guys. What you have to do is you have to basically say n times 1 minus pi, and then after that in this case is going to be 300 times 1 minus the 0.06, which is going to give us, does anyone have that? 282. Okay, 282. Alright, so just by looking at that, then we can test that. Then we already know that our size, it meets the criteria for the normal distribution. So the question was asking us that we have to calculate the probability that at most 25 of these things were made in error. So if it's at most 25, what I usually do is I say 25 over here, then I look at 24, 1 down, and then 26, which is 1 up. If we're looking at it let's say it was on a number line. And then at most 25, that sort of has to do with, let's say you're using the example of money. If someone says, I need at most 25, 25 rand, then you know that you can give them less than that, less than or equal to 25. So if it's less than or equal to 25, that means it's going this side. So then we know that we're working with our probability that x is going to be less than or equal to 25. Right. And then over here, then next what we have to do is that we have to sort of change it because we're using, since now we have to change it to a y. So it's going to be probability that y is less than, and then since you're changing it to y, it has to be either add 0.5 or minus 0.5. Now if we go back to the number line, to determine whether we're going to add 0.5 or minus 0.5, we have to look at what we're trying to include over here. If we added 0.5 over here, then we get 25.5. And if we subtracted 25, then we're going to get 24.5. And then, so we're trying to get everything that's over here. So if we wanted to do that, we could subtract. We're going to have to add 25 over here, which is going to include everything. So we're going to use 25.5. So then we're going to say the probability that y is less than 25.5. And then if we're trying to work that out, then what we do is we follow the formula. Now we need to change it to a z value. So then you can just go like do it on the side over here or something like that. Then we just know that the formula for this is going to be z is equal to the y minus the mu divided by the variance. And then the variance is sort of similar to what we tested over here, but it's not exactly the same. The difference is our variance is going to be equal to, the variance is going to be equal to the n, and then it's going to say pi 1 minus pi over here. So then in this case it's going to be variance is equal to, the n was 300, and then our pi was 0.06, and then this was 1 minus 0.06. Sorry, what?
Question.
Yeah.
So I was gonna ask him that isn't standard deviation that isn't like invariance, like the notation that you use.
Oh, sorry. Yeah. Yeah, you're actually right. So this over here is for what's it called? This is for the variance. When this sign over here is standard deviation. So then, what if we wanted to calculate that? We're gonna have to, what's it called? It's gonna have to square root this whole thing over here. So it's gonna be 0.06. Yeah, thanks for that. 1 minus 0.06. Can someone work that out for me, please?
What's that number in the second bracket?
This over here is 1 minus 0.06. Yeah.
4.1134.
Okay. 4.1134. Alright, sure. We're trying to keep it to 4 decimal places to keep it as accurate as possible. We're not, yeah. So then we're going back to this formula over here. What we have, it's going to be the z value is going to be equal to the y, which we got over here is 25.5. 25.5 minus the mu over here. Sorry, yo. I actually forgot to calculate what the mu is. But
You have it
do I have it?
on top. 18.
Oh yeah, 18. Yeah, sorry. Then 18 over this number over here, which is going to be 4,1134. And then can someone please just tell me what that would be?
$1.8233.
Okay. Then we know that z is going to be, we're trying to populate. Z is less than
8233.
1.8233. Okay,
It's 31.
What? 8233.
8233. Okay, sure. Then when we have this, like our z value works with less than, so it's not really necessary for us to do much about that. So then we can go back to our tables and then find z of 1.8. What's it called? You can really now you can sort of what's it called? You can exclude this part over here because that's not in the table and it rounds up to that. So it'll be 1.82, which is going to be 0.96562. And then we're going to say it's equal to 0.96562. 6.562. Alright, so if we go back to the question, you don't really have to like summarize it or something, but just for understanding's sake, it has to do with it was the mistakes with the counting, like what's the probability that they're going to find an error that at most, what's it called? Yeah, that at most 25 of these things are going to be an error. So that's the probability that we're looking for. Okay.